Welcome back to another Science Explainer video. Today, we are talking about heat transfer by radiation. What makes it unique? Well, unlike conduction and convection, radiation doesn't need any medium to transfer energy. Whether it's the warmth we feel from the sun or how your remote control sends signals, radiation is constantly at work. Let's explore this invisible power of electromagnetic waves and how it affects our everyday lives. Radiation is the transfer of heat energy through electromagnetic waves. Unlike conduction and convection, which require particles or matter to transfer heat, radiation can occur through a vacuum. The most familiar example is the heat we receive from the sun, which travels through the vast emptiness of space to warm the Earth. Here, heat is transferred in the form of infrared radiation, a type of electromagnetic wave. Other forms of electromagnetic radiation include visible light, ultraviolet rays, and microwaves. But infrared is primarily associated with heat transfer. Since radiation is a form of electromagnetic energy, it travels at the speed of light, approximately 300,000 km per second in a vacuum. All objects emit some form of radiation depending on their temperature. Hotter objects emit more radiation than cooler ones. For instance, the sun emits a vast amount of radiation, while cooler objects emit much less. Now, let us look at some practical examples of radiation. The sun is the most significant radiant heat source. Without radiation, the Earth would be too cold to support life. In a typical household heating system, radiators emit infrared radiation, warming the surrounding area. Heat lamps are used to keep food warm. Heat lamps radiate infrared energy to warm up objects in their vicinity. Infrared cameras detect infrared radiation emitted by objects to capture images based on heat. This is useful in various applications like night vision and search and rescue operations. Now, let us explore how radiation works. Infrared radiation carries energy through electromagnetic waves. When these waves strike an object, they are absorbed by the atoms and molecules within the material. The ability of the object to absorb infrared radiation depends on its material properties. Darker and rougher surfaces generally absorbing more radiation. What happens once the radiation is absorbed? The energy from the infrared waves causes the atoms and molecules within the object to vibrate more vigorously. This increased vibration corresponds to an increase in the kinetic energy of the particles. As the object heats up, it also begins to emit its own thermal radiation. The hotter the object gets, the more radiation it emits. This emission can be in the infrared spectrum, or, if the object gets hot enough, in the visible spectrum. Think of a metal rod glowing red hot or the filament in a light bulb. The increase in molecular vibration manifests as a rise in temperature. Remember, temperature is a measure of the average kinetic energy of the particles in a substance. As more infrared radiation is absorbed, the object's temperature continues to increase. In some cases, depending on the material and the temperature reached, other physical changes may occur. For example, solids may expand, liquids may evaporate, and some materials may even melt or undergo chemical reactions. Now, what are some of the factors that affect radiation? 1. Surface color and texture. Dark, matte surfaces absorb and emit radiation better than light, shiny surfaces which tend to reflect radiation. For example, on a hot day, a black car heats up more than a white car. 2. Temperature. The higher the temperature of an object, the more radiation it emits. For example, the sun, at about 5,500 degrees Celsius, emits significantly more radiation than a campfire. 3. Surface area. Larger objects radiate more heat than smaller ones, assuming they are at the same temperature. What are some of the real-world applications of radiation? Infrared cameras detect heat emitted by objects, which is used in military, medical, and environmental applications. Solar panels absorb radiant energy from the sun and convert it into electricity. Spacecraft use radiation to keep their equipment warm in the cold vacuum of space. Earth's atmosphere traps some of the sun's radiation, keeping the planet warm. This is also the principle behind greenhouses used in gardening. Radiation is responsible for about 70% of the heat loss from the human body. The Earth itself radiates heat back into space, which helps maintain the planet's energy balance. Infrared radiation is used in remote controls, which is an everyday example of how we interact with the electromagnetic waves. To wrap things up, heat transfer by radiation is happening all around us. From the sun's rays warming our planet to the glow of infrared cameras, radiation plays a crucial role in our lives. Next time you step into the sunlight or use a remote control, remember you are experiencing the invisible power of radiation in action. Thanks for watching, and I will see you in the next episode.